Okay, so as mentioned in the email this video is attached to, a person is standing with his arm outstretched in a horizontal position. The weight of the arm is 30 newtons, and its center of gravity is at the elbow joint, 27.5 centimeters from the shoulder joint. The deltoid pulls on the upper arm at an angle of 15 degrees above the horizontal and at a distance of 12 centimeters from the joint. What is the magnitude of the force exerted by the deltoid muscle on the arm? Well, the first thing I did here was draw an illustration of what the question was stating. Um, Contrary to what you might think, that does not look like a board. That looks like a perfectly drawn artist rendition of an arm. And it shows my forces acting on it that were mentioned in the question. Now the arm is in equilibrium, so we can apply the conditions for the equilibrium, which was my equation up here, which is that the sum of the forces is equal to 0, and the sum of the torque is also equal to 0. And then when I was calculating my torques, I chose the rotation axis at the shoulder joint because then the unknown force, F sub s, which acts on the arm at the joint, has a 0 level arm and produces 0 torque. So with only one unknown in the torque equation, I was able to solve immediately for F sub m. And in doing so, my first step was that the gravitational force is perpendicular to the line between its point of application and the rotation axis. So gravity produces a clockwise torque with a magnitude of the torque is equal to F sub r. F times r is equal to 30 newtons times 0.275 meters is equal to 8.25 newtons per meter. And then for the torque due to the F sub m, I was able to find the component of F sub n that is perpendicular to the line between its point of application and the rotation axis. And since the line is horizontal, I needed the vertical component of F sub m, which is F sub m sine of 15 degrees. And then the magnitude of the counterclockwise torque due to F sub m is equal to my equation here, which is that the torque is equal to the F perpendicular times R is equal to F sub m sine 15 degrees times 0.12 meters. And then the sum of these torques is going to be 0. So with the usual sign convention, I have my equation here, which is F sub m sine of 15 degrees times 0.12 meters minus 8.25 newtons times meters is all equal to 0. And then I was able to solve for F sub m here with my equation of 8.25 newtons times meters divided by sine of 15 degrees times 0.12 meters. I get that the magnitude of the force exerted by the deltoid muscle on the arm is 270 newtons.